Hello guys, today we're going to talk about computer vision. As you know, computer vision is a really important branch of artificial intelligence. Today I'm going to review an article that actually came across this article a few weeks ago. Sai Force published this report about computer vision in 2024. And I thought it's interesting and I just wanted to share this with you. So computer vision is predicted to have over $50 billion market in 2030. Only a few years from now, they have predicted that computer vision is going to have such a huge market. And as you know, computer vision is about working with visual inputs. A lot of people know about AI in terms of natural language processing and chatbots, LLMs with OpenAI ChatGPT, but a really big branch of AI is in processing images, and that's computer vision. And as you can see right now, the market for computer vision is about $20 billion in 2024, and it's forecasted to double in only 6 years to about $50 billion. Computer vision has a very simple data pipeline. You basically capture your images using some sort of camera or visual sensors, and then you process that raw data, those images or videos, to refine those data and make it ready for the computer vision models or AI models. You get your data through the camera, and then you do some pre-processing, make sure the images are following the structures and the format for the computer vision models. After that, you have feature extraction, which in this part you look for objects, patterns, any sort of cues in your images. If you are performing different tasks in computer vision, for example, object detection or image segmentation or image classification, this feature extraction step is very important, and it's going to detect distinct elements in the image. The modern computer vision is mostly about machine learning, and just to be honest, is mostly about deep learning. Machine learning comes in two different approaches. One of them is supervised learning, where you have a data set of images and you label those images. For example, you say, well, these are images of cars, these are the images of pedestrians, these are images of traffic signs, right? So you label all those images and you create this data set for supervised learning. So your AI model can learn about those images with those labels. Another method which is becoming more popular is unsupervised learning, where you don't label the images and the model can learn about the images over time. Meta, Facebook has some huge unsupervised computer vision models that are trained over millions of images without any labeling. And they're really powerful, and they're being used for a lot of applications. Deep learning has very classic use cases. We call these like computer vision tasks for object detection and image segmentations. And there are a little bit like finer subcategories for these. But the main idea is classify images, detect objects in the images, and then find the boundaries of each object in the image. Here you see this picture, the street view. There are cars here and there are houses. And then on the right side, you have the object detection. There are cars here, and you see there's a label and there's a bounding box. They show where exactly each object is detected with the bounding box, and there's a label on it. This is object detection. But down here you have image segmentation. This not only shows the area where the object is located, but also is so accurate down to the pixel. It shows you exactly which pixels belong to which object. You see all the cars are exactly defined in this image. Object detection up here has a lot of use cases in manufacturing, in agriculture, in like industrial works. But image segmentation has a lot of applications in healthcare, in advertisement marketing, in graphic design, for example. Computer vision is being used for real-time processing. So, for example, for security or robotics, you deploy these computer vision models on a robot or on security cameras so they can process those images real time. And then another part of computer vision, which is a little bit more well known these days, is generative AI, where you generate images instead of just detecting images and objects in the images. You generate images with those objects. Everybody knows about Midjourney and DALL-E, Stable Diffusion. These are popular frameworks for generating graphic images. That's a huge part of computer vision also. Now we're going to talk about the trends and applications of computer vision these days. Uh, there are infinite use cases for computer vision, but here we only talk about the top 3 or top 4. In retail, there's a report that says about $33 billion is the market for computer vision in 2025. So next year, the market is going to be really big in retails. In Walmart, Target, you see they have cameras everywhere, and especially at the checkout, they're using computer vision to track exactly who's checking out, like what products you are checking out. All of that is being captured by the camera and processed real time using computer vision models. Checkout line here, and then you see these bounding boxes for object detection, and then you see smaller green lines and blue lines in here. These are pose estimation models that can detect the joints on human body, and they can detect if you're walking, you're sitting, what you're really up to real time. So if customers are moving or they're waiting in a line or they're checking out, you can detect all those activities with high accuracy. If you want to restock the inventory, or if you see the shelf is empty, you need to put stuff back on the shelf. Computer visions and robotics are really taking over the manual label. Space and queue optimization, again, in the lines for the checkout. If there are a lot of people building up longer lines, they can detect that using computer vision. Another major use case of computer vision is in healthcare, for a lot of detecting any sort of cancer or any sort of problem in the medical images. Uh, this has been like a very mature branch of computer vision in healthcare. Images, spatial image segmentation for diagnostic processes and analysis. Another one is for the surgical assistant. Computer vision can really help with that. Monitoring patients for patients that need 24/7 care, and it's really expensive to have a nurse all the time watching people. Computers can do that, and computer vision can monitor patients. Next sector of computer vision application is in manufacturing. Deloitte says 58% of firms are planning to implement computer vision, which is kind of low, to be honest. Computer vision was good enough 5 years ago for manufacturing. A lot of modern firms already started implementing, but it's always good to see more and more are joining the party. One use cases of computer vision in manufacturing is quality assurance and quality control. Computer vision models can detect that with pretty high accuracy. Another task is process optimization, predictive maintenance, inventory management. For all of these, computer vision is being used to enhance the productivity and optimization of manufacturing. Sometimes they use drones for real-time inventory checks. Drones are a good source of image capturing, and a lot of use cases of computer vision come from drone images, especially in agriculture, which is next on our list in this article. Precision farming, sustainable farming, yield prediction. These are all the use cases for using computer vision and drones for agriculture. I remember I worked on a project in forestry. We used drone images. At the time, it was like early 2020. it's fascinating how you can really use computer vision to process a huge area that nobody can really go and inspect it on foot, but you can use drones to capture all those images and process it with computer vision models in only a few seconds. That was a lot of potentials and the upsides with computer vision. Now let's talk about the challenges. Let's get real with computer vision and applying computer vision to actual use cases. So, biggest problem is quality of raw images. To be honest, I'm not all that concerned about this. Maybe 4, 5, 10 years ago, this was a big issue, but these days, especially with all the fancy cameras that everybody has, even drones have really good high quality cameras. Uh, Image quality might not be the biggest problem. There are tons of data augmentation techniques that we can use always to increase the accuracy of our models and the input quality. Next is real-time processing. So this could be a problem sometimes for, let's say, monitoring traffic or in retail, monitoring people moving around quickly. That's a lot of computational uh, resources needed here for real-time processing, and GPUs are being used for AI these days, and access to these GPUs might be a problem. So computational resources is definitely a challenge here. If you want to push the process to the edge devices, it's going to be a little bit of burden for the users' devices to compute all of this. Next, data labeling. Data labeling has been a pretty big challenge for computer vision. Like I mentioned earlier, for supervised learning of computer vision models, you need to label data, and it's not always easy to do that manually. But in the future, I'm seeing more and more automation is coming for labeling images, and there are bigger vision models. We call them large vision models, LVMs, are mitigating this problem to some extent. So you don't need to go and manually label images and prepare your data set, or you can just use unsupervised learning for a lot of use cases. Sometimes you can just go and use models that are already trained, so you don't even need to do any training. Next problem is scalability. This is sometimes challenging because computer vision models that are specifically trained for a specific data set cannot be transferred to another domain and be used for another use case. So it limits their scalability because they're not very easy to generalize. This again with the large vision models hopefully will be resolved to some extent. Ethical and privacy concerns are the biggest challenge with computer vision, I believe. We all have like security cameras these days, and you feel uncomfortable just leaving these cameras on all the time because of privacy concerns. In healthcare, if you want to use cameras for monitoring patients, for example, privacy is a big issue. In public places, probably not a big issue, but for security, for monitoring in sensitive areas, you need to take care of privacy before deploying computer vision solutions. And at the end, this article talks about Sai Force use cases of computer vision. They have pretty interesting use cases here, using cameras for space analytics. So they basically use a cluster of cameras in a store, in a manufacturing firm, and then they process those images for spatial analytics, which is a really interesting use case I never heard of. Using drones for rooftop damage detection. So roofing companies take pictures, process all those pictures of houses and see which houses need a roof project. A very interesting use case. And this one is about insurance automation, automating claim assessments. I filed for windshield replacement for my car, and then they told me, download this app, take a picture of your car, and then submit it, and then they use computer vision automatically to process the windshield images and verifying the claims on the insurance. This is being automated more and more these days, thanks to computer vision And then another use case for crop prediction systems in agriculture. They're using satellite images to identify harvested sugarcane from fields and its sugar level. So that's pretty interesting use case of computer vision. Advertisement has a very good use case for computer vision, and that is automated video cutting. Everybody who's doing YouTube or video editing these days knows that computer vision is really helping with a lot of editing and video editing. So that's also interesting. Anomaly detection in manufacturing. So again, faulty parts like damages to the manufactured pieces, these can be detected automatically with computer vision. That reduces the cost of manufacturing process and everything. A very good use case of computer vision. Right, hope you enjoyed and you learned more about computer vision. This was a very interesting article. If you feel like there is use cases of computer vision in your business, or you need help with implementing computer vision, object detection, image segmentation, just send me a message or send me an email. I'll be in touch with you soon.